For our first lesson here in Algebra 2, we're going to start a little bit down the way. I want to make sure that we can do some actual algebra before we sort of revisit some algebraic concepts. Just kind of make sure that we're doing things well and correctly, and if we need to stage any sort of interventions early, we can sort of address that. So we're going to jump in and do some basic stuff. This week, or this lesson, we're going to do graphing. Next, we're going to do systems by substitution and elimination. So the algebra is going to get a little bit more intense. And then we'll sort of take a step back and look at some big pictures and then kind of continue on with the rest of the course. But we're going to start kind of in the middle of Unit 1 with linear systems. Our goal is to make sure that we can have a variety of methods to solve systems of equations. This is not new. Nothing here is going to be new today. It's stuff that you did in Unit 7 of Algebra 1, but it's been a couple years. You may have done a little bit starting in Unit 6 and Unit 7 and Unit 8 of Geometry last year, but here we go. Let's go ahead and take a look at a little bit of graphing review, make sure that we can graph lines. Again, nothing new here. This is stuff that you have done before that you should be very confident with, comfortable with, and hopefully competent with. And so a lot of words there. For graph A, we're going to graph the line y equals 2/3 x minus 5. We'll find the y-intercept at 0, -5. The rise over run is up 2 over 3, up 2 over 3, up 2 over 3, or down 2, back 3. Down 2, back 3. We have the dots, we connect the dots, we could make a table of values if we wanted. We could explore those fancy pants grapher calculators and have them help us graph the line. But here is the line for y equals 2/3 x minus 5. That would be the graph there. For letter B, we have this equation 6x plus 3y equals 12, and there's a couple different ways we can do it. We can graph using intercepts, where we know if x is equal to 0, if x is equal to 0, right, for the y-intercept, then y would equal 4, because positive 3 times 4 would equal 12. So 0, 4 would be a y-intercept. And if y is equal to 0, that's the horizontal line, y equals 0 is actually the x-axis. If y equals 0, then x would equal 2. 6 times 2 is what makes 12. So 2, 0. And that would give us these 2 points. You know from geometry, if you have 2 points, then you have a line. It looks like it's down 4 over 2, which is the same as down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And so we can continue that pattern on if we identify the slope. Or we could maybe graph that a little bit differently, right? We could go ahead and get the y by itself for letter B, and we could have 6x plus 3y equals 12. If I get y by itself, which is how most of us probably did this in our Algebra 1 and pre-algebra classes back in middle school, and maybe in your first year of high school, we would divide both sides by 3, and so we get negative 2x plus 4. And so we could graph it that way, just like we did over here. I already talked about how vertical lines are of the form x equals. We talked about x equals 0 as the vertical line. So x equals -1, 2, 3 would be the vertical line, where x is equal to -3. Here is x equals -3. That's letter C. For y equals 5, that is a horizontal line. Y equals 0, 1, 2, 3, 4. That's the point 0, 4. And then 5 is that horizontal line where the y values are all 5. This is y equals 5. This is letter D. And then y equals 3x. This is the same as y equals 3x plus 0, or 3 over 1 times x plus 0. If that's what you need to do from your Algebra 1 days to make sure that you know how to graph that line, great. Or you can just pick values of x. If x is 0, then y is 0. If x is 1, then y is 3 times 1. If x is -1, then y is 3 times -1. All right, and so we can plot each of those x comma y, so it looks like it's the slope of up 3 over 1, up 3 over 1, up 3 over 1, or back 1, down 3, back 1, down 3, back 1, down 3, and that would give us this very steep graph because the slope is 3, so that means we're going up 3 times every time we go over 1. I was off a little bit on my table there, or on my graph there, but here is letter E, y equals 3x. Now here's what I want you to do. I want you to self-assess. Is there any part of that that you're like, I don't know how to graph that line? Okay, that is not the end of the world. It doesn't mean that you're in the wrong class, but that's why we're starting here instead of hitting this in 2 or 3 weeks. If we get this identified early and we need to do some interventions, you need to work with your Algebra 1 teacher, you need to come visit me in Math Lab, then we will take care of that at that time. But there's an expectation that you've taken Algebra 1. Yeah, I know that you did some graphing in geometry. And so here in Algebra 2, the expectation is that you can do it. So please make sure that you can graph lines, because if you can't, it's going to make for an awkward year for us. We also will have some technology that can help us with the graphing as we move on. But it's important that you self-assess there and say, I can graph those lines, or I don't know how you did that. I don't know how you did any of that. We're going to talk about systems of equations. Again, nothing new here. This is information that you would have explored in Unit 7 of Algebra 1. A system of equations is where you have 2 or 3 or 4 or 5 equations, and they use the same variables. Generally, we're going to focus on 2 equations when we have 2 variables. In the next couple days, we'll have a system that has 3 variables, and there's going to be 3 equations. It's going to sort of up the ante a little bit in the algebra that we will be doing. But a linear system is where the system, all the equations in the system are linear equations, are all y equals mx plus b equations. You should remember that idea of y equals mx plus b, where m is the slope, b is the y value of the y-intercept. And if we have 2 equations that are in y equals mx plus b form, or like letter B was, where we could get it into y equals mx plus b form, then we can solve the system by graphing those equations. And so that's actually what we're going to do here. While we can solve by graphing, there are other methods that we're going to learn in the next lesson. But first, let's go ahead and make sure that we can graph these. And so we have x plus 3y equals 2, which means that 3y is equal to the opposite of x plus 2, or negative 1/3 x plus 2/3 is going to be our equation for our first one. Next, we have 3x plus 3y equals negative 6. So here's our first equation, our first y equals mx plus b. Next, we're going to have our 3y's are equal to subtract a 3x from both sides, equals plus negative 6, or minus 6. How about I just write minus 6? And then we will divide both sides by 3. So I'll get negative 1x, or the opposite of x, minus, and then of course 6 divided by 3 gives us 2. So we have these 2 equations, and now our system can be written as y equals negative 1/3 x plus 2/3, and y equals the opposite of x minus 2. I can graph both of those lines, and of course we can call it good. So we'll start with this, with about 2/3, but then we'll go down 1 to negative 1/3, and then over 3. That will take us about there. It's a little awkward, but here we would have actually this point at 0, 2. And so, I'm sorry, at 2, 0. And so what we may actually want to do, since this is kind of an awkward example, is we may want to make a t-chart, like a table of values, for x and y equals negative 1/3 x plus 2/3. All right, I know that if y is equal to 0, that x will equal 2, which means that I can use the slope of this line to go down 1 over 3 to make this maybe a little bit easier. Down 1 over 3, down 1 over 3, down 1 over 3, or back 3, up 1, back 3, up 1, back 3, up 1. Again, if you have that grapher calculator already, you can let your grapher calculator graph this. But here, we will graph this line. Ta-da! Looks like we did pretty well. And then for the second line, the opposite of x minus 2. You can see that point of intersection. You can see where that point of intersection is going to be. I don't have to put every single dot on there. I don't have to make every single x comma y table, but we can graph those lines and find the point of intersection. So the point of intersection here is the point negative 4 comma positive 2. So the solution to our system of equations is the point of intersection. We'll chat about that here in just a moment. Let's do another one. Actually here, you do. You get to do it. So what I want for you to do is, if you need to get y by itself so you can graph those, awesome. If you're going to graph them by hand, great. If you're going to make a table of values, awesome. If you're going to use your grapher calculator, great. But you do need to find the point of intersection to solve this item. For example 2 b. So please do that, and then we'll talk about it in class. Now, here's how this is going to work, because I know that you're going to be new to this. You will get points for doing this, for trying it. All right? You may get the wrong answer, okay, but you should be able to graph those lines. If we can't graph those lines again, that's a problem. If we can't find the point of intersection, that might be an issue, but it doesn't mean it's the end of the world. It means that we might need to practice it some more. So try this to the best of your ability. If you don't try it, then yes, you lose that point, but give it a shot. All right, so kind of in summary, what we're going to deal with here, and this is kind of our last concept, and then I'll have one more example, but basically these are the situations that you may have when dealing with a system of equations. The first is when you have two distinct lines and they intersect in one point. All right, so we call this an independent system, where these lines are independent of each other. All right, it's consistent. I can pick an x here, and it'll give me this output. I put an x in the other equation, it gives me a different output. Or in one specific spot, we see that they do intersect, and for that one value of x, I get the same value of y in both systems. Whoops. So this is actually how many solutions? There is one solution in this independent system. Independent is the word there. Sorry for my handwriting. All right. Algebraic solution is going to be an x comma y. You're going to get an answer that is an x comma y, like in this case. This is an example where the answer is 1 comma 2, if that scale is 1 to 1. Over here, if you have coinciding lines where it's really the same line, just two different equations maybe, and they give us the same exact y equals mx plus b, this is an infinite number of solutions. All right, where every x comma y of one line touches the same x comma y on the other line. This is what's called a dependent system. Dependent. So we had independent and now we have dependent. The algebraic solution is going to come out with like a true statement. Meaning we'll have something like 0 equals 0 or 3 equals 3. All right? If we get a true statement when we're trying to get y by itself in these, or we might see the same y equals mx plus b twice if we get y by itself. So it's kind of a neat trick there to say like, hey, wow, these end up being exactly the same thing. When we're dealing with parallel lines, these lines are in the same plane, but they don't intersect. They have the same slope, is probably how you remember that from your Algebra 1 days. Here there are no solutions, 0 solutions. This is what's called an inconsistent system. Inconsistent. And with these systems, no matter how hard you try, you cannot find the point of intersection because there isn't one. This will yield, if you're working algebraically, a false statement. So you'll get something like 0 equals 2. And that's not true. 0 doesn't equal 2. So if you're working some algebra, some algebraic awesomeness, and you find that 0 equals 2, that's not right. Or if you're working in graphing form, you'd have y equals mx plus one number, and then you'd have y equals the same x plus a different number. All right? And so if you have two different numbers there, that means you have two different b values, two different, if you have different b values, then 0 comma those different b values are those y-intercepts, and therefore those lines will never meet. All right? They're not going to intersect. So what I want for us to explore here is, can we classify these without graphing? All right? Now, obviously, some of us want to go ahead and use our graph paper and try to graph these, or we're going to use our grapher calculator and try to type them all in. You end up doing too much work. So instead, I would like for us to do less work, right? And so I'm guessing you would too. The equivalence there is that sometimes you have to use your head a little more to do less work, all right? You can work, and then you don't have to think about it at all. And maybe that's the way that some of you want to roll, but I'd rather that we get to think about these. So if I were to get y by itself here, I'd have y equals negative 3x plus 5. I'd subtract 3x from both sides. Over here, if I got y by itself, I'd have 5y equals negative 15x plus 2. And then I would divide both sides by 5 to get negative 3x plus 2/5. I would have this equation and that equation. These are same slope, but a different b value, which means that these are parallel. Whoops. Parallel. This means that this system is inconsistent. There is no solution. Over here, y equals mx plus b. It's already in y equals mx plus b form. Awesome. Let's add 4x's on this bottom equation. 2y equals 4x's and 6. Divide both sides by 2. We get 2x and 3. It's the same line. All right, these are the same equation, same exact equation. If these are the same equation, then that means that this is a overlapping graph. They're the same line, right? Same line. And so that means that this is a dependent system. And there are infinitely many solutions. All right? The last one, if we get y by itself, I get the opposite of y equals the opposite of x plus 5, which means that positive 1y would equal positive x minus 5. That's equation number 1. In equation number 2, I would just subtract 3 from both sides. That's pretty easy. And so I get these two equations. Different slope means that these are different lines, and they are not parallel. So this is what's called an independent system, which means that there is one solution. It doesn't ask us to find it. That is not the goal. Classify without graphing. And so there's one of kind of each scenario. All right? So that should kind of round us out. That should be kind of the end of things today. What I would like for you to do is do your best to take a picture of that work and upload it to Google Classroom. Let's see if we can figure that out.